All right, so I just emphasized three elements in the realist curriculum that are prized and honored, that is to say the sciences, physical education, and art. And I singled those out in marked contrast to idealism because we do know from the history of idealism, science, physical education, and art are things that tend to be at best de-emphasized, or in many cases in idealist education are consistently set aside and not included in the curriculum. By contrast, one of the great marked historical contrasts, especially as we get into the modern world, is that science, art, and physical education have honored and central places in the realist curriculum. Now, I want to return to this issue of theory-practice integration that is very important to the idealist and say more about that. Last major unit, when we looked at idealism, one of the themes that's very important in idealist education tends to be a theory-practice dichotomy, the idealist emphasizing the theoretical and the abstract and not so much being interested in practical applications and how things work out in the natural world. The exact opposite is true as a strong and marked philosophical and practical tendency for the realists. And so I want to give a couple of examples that illustrate what I take to be clear examples of the idealist emphasis of theory and practice being integrated, as well as another contrast to the idealist, that being the idea that education and pleasure should be integrated. One of the things that we again can contrast to idealism is the notion for the idealist that education is something that one should do as a sense of duty or obligation, and it's not something that is going to be enjoyable. That is, again, in marked contrast to the realists rather, who believe that education and pleasure should be fun. Education should be a source of happiness. So integrating theory and practice, integrating education and pleasure, or education and happiness, three examples that illustrate that, I think, perfectly. Take younger kids. First example would be mathematics. In many cases, kids are not particularly interested in mathematics, particularly if we teach mathematics and arithmetic as a matter of dry, abstracted rules that are disconnected from anything that's going on in their lives. Suppose we have, though, some younger kids who are 8, 9 or so years old, and it's autumn and it's the end of the baseball season, and you know, at least in America, that many of the kids in your class are baseball fans, and they're intensely interested in what teams are going to make the playoffs and what teams are not going to make the playoffs. So suppose we said, for example, that the Chicago White Sox are 1 game behind the Toronto Blue Jays, but there are 5 games left, and the kids want to know, are the Chicago White Sox going to make it to the playoffs or not? Well, then math starts to become important to them, because that then gives them a set of arithmetic tools that they can figure out for themselves with various kinds of scenarios. If there are 5 games left, and the Toronto Blue Jays lose 4 of those games and the Chicago White Sox win 3 of those games, then the Chicago White Sox can win the pennant. Now, that is mathematics. There can be a number of other scenarios that can play out, and we can play out all of those scenarios arithmetically, but the students are going to be motivated, and they can see the practical value of that